Hey guys, so all the problems that we've looked at so far had an object moving on the horizontal axis, maybe this way, or maybe this way, or maybe even at an angle, but it was always on the floor. Now we're going to look at vertical motion, which is going to be motion on the y-axis with an object either going up or down. All right, so let's check it out. So vertical motion, the first thing is that instead of moving the x-axis, we'll be moving in the y-axis. So instead of having things like delta x and vx, we're going to have things like delta y and Vy. Okay, now free fall is the first thing we'll cover. Free fall is what happens when the only force acting on an object is gravity. So if the only force that acts on an object is gravity, we say that the object is in free fall. Gravity is a force, so the force of gravity can be represented with Fg. There's a few other representations, but we'll stick to that for now. It's in free fall. You can think of it as the object moves freely, free fall freely through space without the influence of any other forces, any forces other than gravity, right? So only gravity. So for example, if I have an object here and it's going down and the earth is over here somewhere, so this object's being pulled down by gravity, then this object is in free fall because gravity is the only force, right? Now, if as the object is falling, or as the object is being pulled down, I'm holding onto it with on the string, there's a little bit of tension there, then this is not free fall, okay? Not free fall. All right? Now, free fall, the term free fall is kind of a little bit misleading potentially, because even though it says free fall also applies to objects that are going up. Okay, so it actually has nothing to do with going up or going down. It just means that you're going in the horizontal, either up or down, and that the only force is gravity. So if gravity is the only force, you are in free fall. For example, let's say this object here, the only force is gravity, Fg, but it's actually moving up. Is this free fall? Yes, because it meets the criteria for free fall, which is that the only force acting on it is gravity. All right, so because the only force is gravity, things simplify a little bit, but to simplify them even further, we're going to ignore anything that could affect its acceleration in the y-axis. We're going to ignore things like air resistance, surface area, right? And because of that simplification, all the objects will have the same free fall acceleration. They're all going to fall at the same rates. So it used to be thought thousands of years ago that or not thousands, hundreds of years ago, that if you release two objects of different masses, they would always hit the floor after different times. And in fact, they fall at the same rate as long as you ignore air resistance, right? So which is what we're going to do here. Free fall ignores air resistance, so all the objects will fall at the same rate regardless of their mass. Okay? And they're going to fall with an acceleration of g. And again, g is the free fall acceleration that happens as a result of gravity. G is an acceleration, and Fg is a force, okay? So when I say gravity, I'm talking about the force of gravity. If I'm talking about little g, I have to say the acceleration due to gravity or the free fall acceleration, though very often these words are used sort of interchangeably. There's a difference between them. Anyway, the acceleration in the y-axis in these problems will always be g. And g on Earth is 9.8. Different planets or the moon or whatever, you're going to have a different g. Now the question is it 9.8 positive or negative? It depends. It could be either positive or negative, so I'm going to put a plus or minus here. Okay, g is the magnitude of the acceleration due to gravity is a 9.8. Depending on the situation, it's going to be 9.8 positive or negative, because if you remember, positive or negative in physics only has to do with direction. So you could think of g as being always 9.8, that's the number, but you could have to stick a negative in front of it depending on the direction, okay? So let's do an example real quick and see how that works. So it says here you release an object from rest from the top of a 100-meter tall building. So here's the building. You're going to release it from here, and it's going to fall. It goes to here. So this is initial and this is final. This is 100 meters right here. All right. And I want to know the speed it will have just before hitting the ground. So it's released from rest. So the initial velocity is 0. And the final velocity is what we want to know. What is v final over here? This is still a motion problem. So I need, just like any other motion problem, I need to know 3 out of 5 variables to be able to solve this. And I'm going to have 3 equations to work with. Here's my 3 UAM equations, the 3 equations of motion. The only difference here is that the V's are now not Vx's, they are Vy's. And instead of delta x, I'm going to have delta y. And the acceleration will be an acceleration in the y-axis, which will always be g, right? So we no longer actually have 5 variables, we only have 4 because g is going to be different. It's going to be constant, sorry. So I have 1 variable here, 2 variables here. I need 3 more. Let's list them. And it's the delta y between initial and final. It's the time that it takes between the two and whatever acceleration you're going to have. Now, notice that I wrote delta y, not delta x. The acceleration here is going to be gravity. I'm not going to put a sign just yet. And if I'm falling from a building of 100 meters, my vertical displacement is 100, right? I'm going from the beginning to the end, so the gap that I covered is 100. Now, this 100 is going down because I'm falling down. Gravity is always down, right? This velocity right before I hit the ground is down because you're falling as well. And this has no sign, and time has no direction, right? So what we're going to do is we're going to say that going up is positive. You have to determine whether going up is positive or going down is positive. And for this one, I'm going to say that going up is positive. If you look at this problem, delta y is going down. If up is positive, then down has to be negative. G is going down, so if up is positive, G has to be negative. So, and then this velocity here will be a negative as well. Okay? So now all we have to do is solve. Notice that I have 1, 2, this is going to be negative 9.8. Again, G is 9.8, but my acceleration is negative G, so it's negative 9.8. It's not that G is negative. G gets a negative tacked in front of it. Okay, so I know 3 things. Here's all the stuff I know, 1, 2, 3. And I'm looking for V, so I can solve for V using one of our equations. The second equation works, and it's V squared equals V initial squared plus 2A delta X. This is the way that you were used to using the equation right here, but we're going to make some changes. I'm going to say this is actually Vy, V initial Y, 2, acceleration is G or negative G, and delta Y. So all I've done is kind of rewrite that equation. You could have already written it this way, the second way here, if you want. It doesn't matter, as long as you eventually plug in the right numbers. Okay, the initial velocity in the y-axis is 0. So my final velocity will be the square root in the y-axis will be the square root of 2, negative 9.8, negative 100. So it's the square root of this, which gives me, I have it here, 44.3 meters per second. I left a space here in front of the number so I can put a sign. Is this going to be positive or negative? Now, once you do a square root, you're always going to get a positive number out of a square root. You may not remember this, but technically the square root of 9 is not 3, it's plus or minus 3, because you could have to manually insert a 3 in there. And that's what we're going to do. You look at the diagram, and then you realize that this is going down, going up is positive, so going down has to be negative. So I'm going to force a negative in front of this guy. Okay? And that's because it is going down. So that's my final answer. That's the final velocity. The same thing that we always did. Write your variables, your 5 variables. You need to identify 3 out of 5. Pick an equation, solve. The only difference is that the acceleration is always gravity, and now we're moving on the y-axis. All right? So let's talk more about the direction of G and the sign of G, right? There's often some confusion about that. The direction of G is always down, right? Technically it's towards the earth, but in most of these problems the earth is going to be below you, so it's just going to be down. But the sign, so the direction is always down, but the sign, meaning positive or negative, will depend on your frame of reference. Frame of reference, remember, means how you determine the direction of positive, what you determine the direction of positive to be. If you look here, I chose that going up is positive, but I could have chosen this a little bit differently. All right, so let's check out basically all the possibilities you have. So let's say I decide that going up is the direction of positive, and here I'm going to say that going down is the direction of positive. Okay, so going up is the direction of positive. Let's look at this first. And what happens if you're going down? An object is going down. Well, if you're going down, that means that the direction of your motion is down. And that means the direction of your velocity is down, the direction of your delta y is down as well. Okay, these two, by the way, have always have the same direction, right? If I'm moving to the right, that's the direction of my delta x and the direction of my v. If I'm going down, that's the direction of my delta y and the direction of my v. Acceleration is gravity, and gravity is always down. Now let's look at signs. Going up is positive, so going down is negative. All these guys are going down, so they're all negative. Okay? So this is if you're going down. Now here you're going up. So it's per the diagram there. So you're going up, and that means that the direction of your velocity is up because you're going up. And these two are always the same, so you're going up, so you get an up here. But acceleration is gravity, so this is going down. I said going up is positive. This guy's up, so it's positive, positive. This guy's down, so it's negative. Okay, so that's how that works. Here, if I decide for whatever reason that I want to say that the direction of positive is going down. In this case, if I'm going down, it means my velocity is down, my delta y is down, and gravity is always down. But now I said going down is positive, so I have positive, positive, positive. If you're going down, sometimes it's a good idea to say that going down is positive. Why? Because instead of having 3 negatives, I have 3 positives. And that's better. You don't have to deal with negatives, right? Which can be kind of annoying. If I'm going up means my v is up, so my delta y is up, but a is always down. So going down is positive, so going up is negative, negative, going down is positive. Okay, so are you supposed to memorize all these? No, you're supposed to just understand it. Depending on how you choose your direction of going up, the direction of positive is going up positive, is going down positive, then you have to pick the signs accordingly for your v, your delta y, and your a. Okay, so there's several ways you can do this. Some professors will do it that if you're going up, we're going to say that going up is positive. And some of them will say that if you're going down, we're going to say that going down is positive. And there's some advantages to that. But I think that the way that generates the least confusion is if we decide right here, if we decide to take the direction of positive to always be up. If you do the same thing over and over, it's a little bit easier. Then your AY will always be, your AY is always going to be down, right? And if going up is positive, then your AY will always be negative. So AY will always be negative G. In other words, negative 9.8. Again, it's not that G is negative 9.8. G is 9.8, but AY is negative G. Okay? So, long story short, if you stick to this, your AY will always be negative 9.8. And that's what I'm going to do for all these problems, so I have a consistent way of solving this. All right? So now I want you guys to try this practice problem, and let's see if you can get it.